Hello again. Yeah, time to continue on our project. Yeah, I would really like to do the resource allocation and a linear buffer uploader uh, today, since since that would be a really good offset into actually changing topic and going into the pipeline stuff. I'm sorry, I'm just petting a dog while I'm doing this intro. Yeah, so I'll be doing a bit of setup. We would like something like a data structure of sorts that is able to hold a structure. And we kind of like just want to do a wrapper. Yeah, let me just think how to lay it out. Yeah, so let's close some of this down. This one I will use later. Let's see. We want to create resource DirectX12, and there are different kinds of resources. There are, if we just look up the, create committed resource, create placed resource, and reserved resource. So it all has to do with memory management. When we create a committed resource, everything gets placed on an implicit heap. And we don't have to do the work of actually yeah, we don't have to do the work of actually handling a heap, and we would like to avoid that for now, since heap management will be a more complicated topic, and at the beginning we don't really need to do manual heap management. But of course it's DirectX 12, therefore you have the possibility to do almost all that you want. We would like to create a structure that holds the resource yeah. Generally, resources are continuous in memory and simply sliced accordingly. So yeah, that means that we can, of course, store whatever we want inside our buffer. I'm just wondering whether we would like to yeah, I think let's see. If we, for now, just create an object that is called a D12 resource, we thereby create a that can wrap our actual resource. Let's see, did I use the namespace? I did. Okay. Let's see, we want to use the namespace. And of course we need to move these files. For now we won't be using the renderer, the command queue, or the application device, not either. Yeah, let's close some of these things. Yeah. All right. These are fine to have open. Whoops. So we could always create an empty resource. Whenever we destruct a resource, we want to do something specific. Let's see, it has to be public. We would also like an explicit constructor that takes in an ID 3D12 device pointer. That's what I remember that we have to use. Let's see. Yeah, we called it on the device, so heap properties is a structure. Let's see. These are parameters that we pass in. Let's see. back in the olden days, what did we do? All right. Well, when we all right, so we need to call the method. Whoops, let's create that one and that one. So basically, we want to call the create committed resource. We would like a heap property structure which contains the type, which means that we would like to take in a value for that. D3D12 heap type enum or rather heap type, yeah. So we want that as well. Let's see. Let's assign it to heap type. Maybe I think that there might be heap not heap properties. Yeah, I'm just looking up whatever. So when this takes in so whenever we create one of those, all right, it doesn't matter. Let's see the CPU page property. Yeah, let's just set it to unknown. Uh, memory pool preference. Let's set it to unknown. Creation node mask for multi-adapter proper operations. Both of the last fields are for that, so we just fill them both with 0. There we go. Create. Oh well. Let's see. It doesn't have a helper. Sometimes I look up the helper section to find what gets passed as yeah. Let's see. The heap flags. If we start typing out our create committed resource heap properties, heap flags none. There we go. The resource description, D3D 12 resource description. Let's see, let's pass that one in. And let's see, we want it to be in a common state when we initialize the yeah. And we need to see clear value. It's a pointer, so it can just be null. And then we want to store our com pointer somewhere. And of course it has to be inside the actual object. ID 3D 12 resource resource, and we then, let's see, ID ppv rx, and get the address of that one. And since it's totally unreadable, let's just format it like this. There we go. resource. Release the resource whenever we deconstruct this object. We don't want to throw an exception, but we will probably get a D3D12 error if this fails. Let's see if this actually works. We would like to, yeah, this should be included after. We would like to create a resource during initialization. We would like it for it to, maybe actually we want to store it. Yeah, we don't actually, let's do a section test variables. Yes. Let's move that one. D12 resource and test res. And we of course have to make an initialization method. Also inside this one we will have to include whatever we included in our swap chain, since now that we included in our renderer, we can't be certain that our PCH file gets loaded. Yeah. Yeah, it's not created yet. So let's see. Let's do an initialization method that actually does the same thing. We would like for it's gonna be a void. Let's see. Oops. Let's just move that into our initialization method and call initialize with our device and heap type. Let's see, let's initialize it by using our device and the D3D12 heap type default. Let's see if we get an error. Oh yeah, we haven't actually set any setting, so as you can see here, we got an error and actually got an exception because we weren't able to create it. But yeah, let's see. Next, we of course have to fill out a buffer description. And let's see the resource dimension, either buffer, unknown, or textures. This will for certain be a buffer. So the dimension will be the 3D resource dimension buffer. Then we need to calculate the width. For now it's going to be 0, but it has to be calculated for our content, or let's just set it to 1. And we will set the height to 1, which will always be 1. Let's see. Specifies the depth of the resource if it's 3D or the array size. It's also going to have a depth of 1 since we're not having a 3D. Let's see. It's going to be 1. Let's see. So we actually need to specify the alignment. If it's 0, I think it will just do standard alignment. Let's do it in there. Yeah, I think it's alright to not specify the alignment, but this resource has no MIB level since it's not a texture. Then we specify the format. We don't want a specific format. It doesn't have to have a specific format as long as they're compatible as we go along. Yeah. As long as we all get along. Next, we set the sampling description structure. We just set it manually since we will be using a count of 1 and a quality of 0 since we won't be doing sampling. Next we do the texture layout. We will be doing row major. If you know anything about matrices, you will know what that means. Let's see. Alright, I need to enable caps lock and do this properly. And next, we would like some flags, or rather, we don't want any flags. Yeah, there we go. Let's see if it crashes or rather bugs out now. The alignment buffers must have this field set to that. Well, we got our answer right from the debug layer. Isn't it amazing that, or rather, or 0? Well, we're allowed to do 0 then. That is great. Without this debug layer, things would get so much harder. All right. No error messages. Great. That actually means that we created a resource. Now, how on earth do we know that we actually created something? Well, there are different tools that allow you to debug these kind of things. Usually they are supplied by your GPU vendor. My GPU is an Nvidia GPU, but also actually have an on-chip on CPU built-in graphics card on the or rather built-in GPU inside my processor. But yeah, I'm using, of course, the dedicated GPU, so that means I'm using Nvidia. I'm unsure whether I actually will be showing you how to use the AMD tools, but yeah. Yeah, maybe we will do that if someone really wants to, since I actually am able to uh, use both kinds of software. I just have to, as you saw before, or rather earlier when we did the start of the series, when we fetch the adapter, we can decide to uh, get a specific device that we want to test out, and therefore we can just fetch the AMD uh, uh, GPU if we want to. Alright, but this compiles, and let's just build it in release mode as well. Now we will use Nvidia NSIGHT. Alright. We have an old project. Let's create a new project. YouTube game. And that is absolutely fine. We need to find our application. Our application executable, and I actually think that should be it. We will allow it internet access. Yeah, okay. So it doesn't like that I've enabled the is this actually end? I think this is NSYNC enabled. Yeah. Otherwise it would probably spike way higher. Anyway, it doesn't really matter much. I'll disable it in the future. Yeah, but you press F11, and now we have access to a range of debugging tools. there are no heaps since we have registered none, but we can look up our resources, and lo and behold, we actually have a buffer. Now, isn't that fantastic? We have our back buffer and current buffer, or rather render target view. As you can see, one is in render target state, one is in the common state, which is actually, I think, our transitions. Let's see. If we just jump out into our renderer, when we end the frame, oh, percent. Well, common and percent are the same, so as you can see, it's the same value. So therefore, we actually have a buffer in our common state. We have two buffers since we created those when we create the swap chain. And this buffer has 1 byte of memory, and it's in the common state. It has the base alignment, which it needs to have to be placed on a default heap. The heap is a default type, and yeah, it has a memory address. It has no views pointing to it, meaning that there are no descriptors that reference this actual object. We will get more into descriptors later on. It's not a texture, it's a buffer. Yeah, and if we open it, you can see byte 1, it's simply 0. Depending on our type, we will be using bytes to represent the specific data. So yeah, isn't that great? Then you might say, well, how is this useful? Well, when we have to utilize resources, we have to place them in memory, either on the GPU or the CPU, or in a shared space where both parts of the hardware can access it. As I've mentioned in a previous video, using the Agility SDK, by using DirectX12 Ultimate, you are actually able to create memory locations on the GPU, which the CPU can map directly, which is not really something that you can do in the same way currently. So yeah, this buffer is created on the GPU. It's a default heap, meaning that it's just a GPU heap. Currently, it contains nothing. And when we want to store data in this structure, we have to sort of upload it. That means that we would need to let's say we would need to create an intermediary which resides in our shared memory where the GPU and CPU can access it, and from that buffer we would have to copy the contents of the buffer. So that is what a linear buffer uploader is actually for. But before we do anything, we will just adapt the actual resource here. Since I set the width as 1, it will be somewhat hard to test out something with only 1 byte of memory. The alignment is plenty big, so we should have plenty of space, but we could do something like size of uint 64. Let's say we want to store a unsigned integer of 64 bits. In our buffer. The thing would be the thing that we would need to do would be to create, let's say, this is called the GPU, and this is gonna be called the shared resource. And we will just copy these names so that we don't have to type them out. And we will, of course, pass in the device. But as for the heap type, we see that we have a custom heap. We are really not going to use that. We have a default heap. Oops. Sorry. We have a readback heap, which is actually a kind of heap where it is on the GPU, as far as I remember, and you can somewhat access it, but it's not exactly mapped in a way that or rather, the CPU can read from it, but it cannot write to it. And that is the smart thing in terms of the GPU-based memory, where the CPU can access it as well. But yeah, we don't have that feature set. So let's create a resource that is supposed to reside on the actual shared memory. I think it will be placed in CPU memory, or rather, CPU memory, and accessed by the GPU through the PCI lane. Anyway, let's compile this. Everything works fine. Whoops. Let's see. So when we we would like to of course, let's see. And reset the comp pointer. Let's see. It still crashes. Let's see. Certain resources. Ah, yeah. Okay. Thank God again for our debug. Oh, hi there. Yeah. I actually closed the command list. The problem is that I think the API threw an exception because I tried to initialize a resource in a completely wrong state. Yeah. Uh, Let me show you. Uh, So I just think it's because of the exception. If I don't initialize any of the resources, I think everything should work fine. So, for instance, the last one worked. This shouldn't be giving me any errors. No, as you can see, there's no errors here. So it's because the exception kind of crashes the parts of the API. So of course I need to fix. Oh, sorry, the headset bugged out. Um, I have to be able to pass in what resource type or rather the initial state that we would like the resource to have. So let's see. D3D12 resource state. But thank you for the advice. I spent forever. Oh, I haven't actually looked into those. Do you have an article or something? Feel free to pass me a link. That sounds interesting. I haven't really looked into. Yeah, all right. I'll definitely look into that. Thank you. Let's see. Before I lose my train of thought, I'll just do this. Resource. Whoops. Resource state and initial state, and pass that into. Let's see the resource creation and of course the initialization as well. Whoops. Oh yeah, yeah. Barriers are kind of a hassle. I've implemented a manager just and a simple wrapper for some of the methods that allows us to capture states in the future when we have to synchronize states. But yeah, I mean, like anything that can make it easier would be much appreciated. Is it a part of the ultimate uh, DirectX SDK or let's see. And let's. Oh, do I really have to change the state or? Well, that's weird. Are you sure that you fetched the correct feature level? Because I think the 30 series should support almost everything. except for, of course, the frame generation stuff. But oh, there it was. Yeah, and nothing. And you got no error codes. Let me just enhanced barriers. All right. Let's see, DirectX. Is this the overview you thought of? Yeah, I can't remember if the spec actually does it need you to include the headers. Let's see. Let's see. But it's kind of weird that it allows you to use the feature, but it says your GPU doesn't support them. I reckon that. So it has some sort of compatibility. Let me just check that out. Oh, it opens in another browser. Let me just. Yeah. WDK driver kit. Yeah, maybe. Um, are you using Visual Studio? And have you installed that SDK? Yeah, I'm unsure whether that would give you a weird bug, because if it has legacy compatibility, maybe, yeah, maybe it doesn't really know what to do. The Agility SDK does overwrite some of the headers, I think, or rather not overwrite, but offer replacement. Let's see. Enhanced barriers is also part of the non-preview version. After all, maybe the um, Microsoft article is old. Yeah, it's from October last year. Hmm. Yeah, it's like an extended feature set. Um, yeah, usually DirectX 12 is released with different versions of the Windows SDK, but I don't think Agility ever made it into the actual Windows SDK yet. Um, so it seems like something you have to use as a library of sorts, um, instead of the SDK or original SDK header files. At least that's the same thing with when you want to use the DirectX headers. Let's see, do they have a repo for it? Oh, I have a lot of repos, but let's see. That's not the repo. Maybe even IDEs are able to. The headers I just showed you, these ones. Um, it's um, it's for a somewhat extended DirectX API. One thing is that they update the actual header of DirectX. As you can see from this repo, it last got updated 7 months ago. And they extended the library by creating helper functions. So if you find it tedious to write out different calls, for instance, if you don't want to write out the code to create several instances of resource barriers, there are sort of macros. I don't know if you can read it, but there are macros, not really macros, but extensions of the original types that do a lot of work for you. So it only requires about 1 or 2 lines of code to create default descriptors for objects of different kind. So it also has pretty nice helper features for memory management. For example, this one, let me just update sub-resources. It's just a global function that you can use to pass in a command list, a destination resource, and an intermediary. And if you just segmented it accordingly, it really handles all the logic for you. Um, as you can see here, it's for each sub-resource, make sure that you do a proper mem copy and so forth. Yeah, yeah, exactly. It's a lot of different helpers. I'm unsure whether this is actually also a library package of sorts. Uh, Maybe I should just download them, but I'm unsure. It's a package. Yeah, so it's a package into Visual Studio. Did you install the package into your IDE? Well, maybe you should try that out to see if um, that helps you out. I'm pretty sure they haven't done much to help you out in terms of enabling the API. Yeah, it's really overwhelming. Um, um, One thing is the whole API itself, um, and one thing is the extensions. And I don't know about you, but I actually found the helpers to be more of a distraction because I never really knew what was going on when I used a helper, so I got more confused. And when I had to install it, I had to, uh, yeah, go through a lot of hoops. So yeah, it's way more easy when they just include it as a normal package. Mm, it does include a getting started guide. Okay, seems like they have some run times. Okay, so the agility SDK is loaded into that dynamic link library, and that is saved. Uh, yeah, hopefully it works out. Otherwise, we could look into why not. Uh, yeah, okay. They even did an algorithm for you to check out in terms of what to be sure is working. All right, even with Windows specifications, if you're running Windows 10, I think it comes with. Does it come with Windows 11? I'm not sure. Oh well. It would be fun though to try out some features from it. Let's see. Uh, let's see. Did they provide a feature overview of sorts? New features. Yeah, that's the um, DirectX Ultimate Ray Tracing 1.1 Mesh Shaders. I thought we had mesh shaders. Maybe it's just um, some different version, not hardware specific. Hmm. All right. Well, I'll be definitely checking out those barriers eventually. All right. I should probably just finish this up so that yeah. it it definitely feels like sometimes you get a grasp of something and then something even more advanced comes out and yeah, I guess that's just yeah. That's just how it works. If you're just a part-time hobbyist, or rather not part-time hobbyist, that's nonsense. But if you're just a hobbyist, you definitely yeah, yeah, and they're really, really, really good at updating their documentation as well. I I noticed in a previous video that they had a description of a certain method, I think, where it just said to be displayed, and it was like 1 year ago. It's really it's just so confusing, but yeah. I really like that DirectX 12 is so close to the hardware, and it gives you some. Yeah, could you link it? I'll definitely look into it. Is it just a Microsoft-based one? Oh, and they don't just provide you with a ticket of sorts. All right, that sounds great. Yeah, it's a nice resource to have. Um, have you been? Oh my God, that sounds nice. Probably sometimes even better than to open a ticket somewhere. Have you worked with DirectX 12 for a long time? Thank you. Wow, you're a veteran. Have you built uh, something with it, or ah ah great. Is it inside the gaming industry, or is it inside the something else? Oh, nice. How awesome. Are you the sole programmer, or ah? Oh, that sounds awesome. Must be like a very fast way. Uh, yeah, that's awesome. That's really awesome. So you're gonna do the renderer, and the others do. I'm actually not a programmer at all. I'm just a hobbyist. I work in a different field full time, so this is just my hobby project. But I started to get into DirectX 12 a couple of years ago, and I've been doing it on and off uh, since then. Yeah, it's whenever I have the time. Let's see. Um, uh, well, that's a good question. um, I certainly would enjoy having a job as a programmer, but yeah, yeah. Uh, I'm unsure whether I would actually try to step into programming as a career. Yeah, it would be quite big of a leap, and I've got a fairly fine career in my current field, so yeah, it would be some sort of a gamble. It would really depend on what I could do in my local community, or rather not local community, but what would be available to me at my current city. Uh, and I think I wouldn't be, yeah, I'm unsure whether I would be a good candidate, but yeah. But hopefully this project pans out into something that um, will function properly and perhaps be a stepping stone into something more complicated. And yeah, location and experience, and yeah, of course also motivation. So, but yeah. Let's see. Is it read state? I think so. Copy source. I think that one matches the upload. Generic read. Yeah, probably. I would probably get overwhelmed. And since I enjoy it currently, I kind of like hyper focus when I do it, and I sometimes end up spending a whole day just doing something on a project. So yeah, I think I would really burn out if I had to do it professionally, at least for now, until I learn how to manage my energy. Yeah, it's great that um, I'm able to enjoy it that much, but yeah, I think there's a lot of things I would need to learn to do it professionally in terms of managing myself. Um, I kind of obsess with problems until I have them solved, and sometimes you need to sleep as well. All right. Mm, it seemed to be working, at least compiling with and not. putting out any errors. So let's yeah. You're probably right. Mm. All right, the error that gets posted is does seem to be when I release different parts of the renderer. So yeah, let's see. Maybe, oh, maybe you're right that even when I close, or rather when I destroy the renderer, maybe I should close the command list. Because yeah, I flush out the command queue. I release the swap chain. For now, I release those. Mm. Yeah. So if I test out whether we actually have a command list and uh, let's see, does it reference the yeah, it says that. So let's just cast that one into the graphics command list. And close it. Maybe I actually shouldn't do any of this, because when I release it, I don't want to just reset the command allocator and open the list. I think I would rather just use this. If it's open, close it. Yeah. I think that was it. And then of course, yeah, okay, we need to release the new resources that I just created. But yeah, that was a mistake. I really don't need to reset the commands anymore. It was back when the method only reset the command list allocator, or rather command allocator. And let's, before we reset the device, let's just, oh, we haven't implemented any release methods. these. And did I call it shared? Yes, I did. All right, now destruction should be, huh? Whoops. Yeah, I'm definitely. Maybe it's because, yeah, I think I should just let the com pointer release itself. Maybe. Nope, that's not it. Let's check if it actually is pointing to anything. Yeah, that was it, and no live objects. Great. Great, great. So now we can release an object and actually initialize it again. Great, great. All right, then onwards to the thing that I actually wanted to show. Let's try this out. And a driver bug. Oh well. So if you're watching this on YouTube, as you can see, we have created two buffers. They are 8 bytes, and that is because a unsigned integer or in a 64-bit environment is 8 bytes, and we created one buffer on the default heap and one on the upload heap, as you can see down here. This means that we can access one buffer directly from the GPU, and one buffer can both be accessed from the GPU and CPU. Whoops. And the way that we do that is by uploading the data from an intermediary which has a placement on an upload heap via the PCI lane to the resource that is placed on the GPU. So in order for us to do that, we have to first set some data. And we will be doing that using some different functions. Since it's located in the CPU memory, the intermediary that is, we can copy to it using a memcopy. Or actually, I'm not sure whether it is residing in yeah, I think it's the CPU memory when it's the upload heap, but I would have to look it up. Anyway, let's create a map pointer, just a void pointer, and we would like to be able to actually get our resource. It's not exactly an initialization, it's a getter of sorts, so therefore I'm gonna place it here, get resource, and do this as an inline function. And then we are able to take our shared resource and get our resource and map it. We'll look up the map function later when we do the linear allocator. I probably won't be able to make it today, but yeah, we will revisit it then. I just want to show you how we could copy something from one resource to another. So we map the layout of this resource into this pointer, and now the pointer points to wherever that resource is located. As I've said, I think it's the CPU side whenever it's the upload heap, but yeah. And since it's mapped to the pointer, we can use a memcopy. We pass in the destination, which is our map pointer. We pass in our data. Since we're actually only storing currently a uint64 value, let's call it that, and the answer is always 42. So we pass in a void pointer as a reference, and let's do a size of uint64. Yeah. And then we unmap the whole thing. In general, you can choose to unmap whenever you deallocate the resource. But yeah, for now we will keep it somewhat tidy and do it like this. So if everything compiles and we get no errors, we should now be able to use NSIGHT to look up our information. I forgot to save or what? Yeah, I must have. Oh well. Or, oh, yeah, it crashed. I forgot. Yeah, so we check out our resource. So our upload heap should contain data, which it does. Let's see. The first byte contains 42. Oh, yeah. I'm unsure whether the rest is just padding. Oh, yeah. I think size of is multiples of 8. Yeah, I actually think so. I don't even think it told me. Let's see. If we just do it like that, and then in our resource, of course this has to be dynamically controlled, so we still need to allocate resources with specific sizes. It's just basic memory blocks, so it doesn't matter how many objects, but we should do some computations in terms of what spacing, or rather how much space we should reserve for the actual resources. I think this, let's see, let's close this and try again. Yeah, I think yeah, 1 byte, and it's 42. So right now our buffer on the GPU doesn't contain anything. The one in shared memory contains the number 42, which is great because that is what we um, uh, define the value as. Uh, and for the next compilation, I will just change it to, yeah, 940 for whatever reason, no reason at all. And then we would like to copy our data. And let's see. I actually think that we can record a command in our command list manager. If we get the graphics list, we can copy the buffer region, I think is useful here. So we copy the contents from our source into first the destination. Let's do get resource, and the destination offset is nothing, and we give it our pointer for the shared resource, and we do not pass it anything, and just to make sure that everything gets handled correctly, we pass in how many bytes we want it to take up. And we just record the graphics command. It should get handled during the first frame. This is where you eventually would like a separate copy queue that can handle different forms of data upload. For instance, a ring buffer or a linear buffer that just runs whenever it's needed. So yeah, now we see that we actually have a value inside our buffer on the GPU, and it's the same value as whatever got put into the shared memory. Yeah, so the idea is that in the next episode, I I would like to in part, where did I put it? The roadmap. Sorry for any feelings of sudden blindness. Um, yeah, we would like to be able to allocate resources with specific sizes, and then since we will be doing a lot of different buffers that is going to reside on the GPU only, we would just like a interface with a linear buffer uploader that just makes sure that everything gets um, uploaded as intended, or at least records the command list calls for that, and then we don't have to create an intermediary every time we want to upload something into our GPU. We just create the committed resource, and then the uploader or allocator or whatever we want to call it, um, it just it iterates through, or rather chunks the data and uploads it. Um, yeah, since creating two resources every time and doing this manually is rather cumbersome. Yeah, I actually think that maybe we sliced the the byte up and ended up getting a wrong value here, because let's see. Uh, well, if I close it too fast, it gives me a null pointer. I guess that's fair if it hasn't really done doing its thing. Uh, I should bug fix that. Let's see. Fix crash null pointer when closing the application too fast. We will just do some null pointer checks. since it's inside the structure, it doesn't really matter performance wise. Yeah, so let's see. I wanted to test out whether it was true that it actually ended up slicing the information. Let's see. Yeah, yeah, yeah. So 1 byte can only contain a number up to, yeah, 172. Yeah, so the whole integer is actually these 8 bytes. It's not because it does multiples of 8. Oh well. Yeah, but I'll be wrapping up. I'm unsure whether I will be doing more episodes today. For anyone watching on YouTube, feel free to comment, like, or subscribe. Read my code. I really hope that you get it working. Otherwise, feel free to leave a message, and maybe we can look into it together if it still is not working properly. Thanks for all the help and the different references. I will definitely be checking out the Discord and probably also the SDK.